Hello friends. There are a lot of comments on the confusion of the relation between pressure and velocity of flowing fluid. We will try to clear up this confusion in the upcoming 3 videos. But let's first understand the first term, and that is pressure. Pressure. Pressure is the force applied perpendicular to the surface of an object per unit area over which that force is distributed. Mathematically speaking, P is equal to force divided by the area. Pressure is a scalar quantity. This means only value to define the pressure, not direction. It is vector area and normal force which are inputs for pressure. It means surface area. We are only taking into account projected normal area. A system under pressure has the capacity to perform work on its surroundings. Pressure is a measure of potential energy stored per unit volume. It is therefore related to energy density and may be expressed in units such as joules per cubic meter. Now let's talk a little bit about fluid pressure. Let's assume a container with enclosed fluid. There are a lot of fluid particles moving in random motion. These random motions cause the collision of particles with each other as well as the surface of container. They perform some work on surroundings by applying a force. So that is fluid pressure. Here, the concept of atmospheric pressure can be understood. Atmospheric gas particles collide with liquid particles and they create pressure on fluid, which is known as atmospheric pressure. For a stationary fluid, Pascal's law states that the pressure applied to any part of the enclosed liquid will be transmitted equally in all directions through the liquid. So, pressure in each and every direction is the same without any change of value. You can easily find the mathematical proof of Pascal's law on any platform like Wikipedia. We can take another example. Let's take 3 containers as shown in the figure. Which one has higher pressure at the bottom of containers? Well, all of them have same pressure. Because all of them has same external pressure, and that is atmospheric pressure, and pressure is dependent on height, not the shape of container. So, when a swimmer is swimming inside a pool, it depends upon depth at how much pressure he is experiencing. If we take the same container and measure pressure at different heights, then we will get different values. In fact, more values at the bottom. It is so because of above mass or volume is creating more and more force as we are increasing the height. Pascal's law has many applications like hydraulic lift. We can lift weights with less effort, just like mechanical advantage. But mind here, we are talking about the pressure inside or on the fluid, not on the side wall of containers. Pascal's law is mainly giving the idea of enclosed fluid or the energy stored inside the fluid to perform the work on surroundings. But what about the moving fluid? Then the fluid has dynamic pressure too, because of the velocity of the fluid. So now fluid has both static as well as dynamic pressure. Wait, we haven't discussed the static pressure. Nope. We have discussed it. It is just the same as we discussed earlier in the video. Algebraic summation of both terms gives total pressure. The law which gives an idea of how fluid pressure changes under flowing conditions is Bernoulli's principle. That is our second video. Stay tuned for our next video. If you have liked our video, then subscribe to our channel and press the bell icon to get the latest updates. You can reach out to us by email, or you can follow us on Instagram.